In this video, let's look at ratios and proportions. Proportions. So far we are familiar with the idea of ratios. Let's have a look at proportions. We'll begin by taking the example of a teacher-student ratio of a school, which is the ratio of teachers in school to the students present there. It is suggested by various government authorities that the teacher-student ratio of a school should be 1:15. This means one teacher for every 15 students. This is what is suggested. Now let us look at our school. So if you see our school, we have 24 teachers and a total of around 400 students. That means our ratio is 24:400 or 24:400. So this is the ratio of teachers to students in our school. Now, of course, in order to compare this and that, we have to reduce this ratio. So let's reduce it by simply by writing 24:400. Now we will divide both 24 and 400 by 4 to get an equivalent ratio. Equivalent, we know equivalent fractions. This is an equivalent ratio. We divided 24 by 4 and 400 also by 4. So we got an equivalent ratio. And since these two ratios are equivalent, we put this double colon in between, and this is pronounced as. So we say 24:400 as 6:100. Then of course we can see we can reduce this further. So we divide it by 2, divided by 2. We get a ratio, we get a new ratio and a new equivalent ratio of 3:50. And so we can write 6:100 as 3:50. Now, normally we keep ratios as whole numbers. Okay, normally we don't keep them as decimals. For clarity, we can use decimals when the principal, that is the main or important term, is reduced to 1. What does this mean? Now, in this case, this is of not much use to us. Why is it not much use to us? Because we wanted to compare this ratio with the ratio given there. Okay, we wanted to compare these two ratios. So this answer, we are not sure, is this ratio greater than this? Is it less? We don't know. Do we need more teachers, or are there too many teachers? So how will we find that out? By reducing the principal value, which is the main one we are focusing. We are focusing on the number of teachers. So let us reduce this to 1. How will we reduce this to 1? So 3, we can divide it by 3. This will give us 1. So we had an original ratio of 3:50. Yeah. As 1:something. What is this something? So we divide. So 3:50. So we divided 3 by 3. So therefore we will also reduce 50 by a factor of 3. So we get 1:. This is around 16.66. So we find that in our school, the ratio of teachers to students is 1:16.66, means more than 16 students per teacher. The recommended ratio was 1:15. This means we either need fewer students or we need more teachers. So now let's look at how we do this. So let's ask the next question. So how many teachers should there be? The next question I can ask is how many teachers should there be? And so we take our favorite letter X. So 1:15 as x is to 400. Now what is this x? We are saying that the 400 students we have, we need to keep those 400 students. The question is, how many teachers should we have? How many teachers should we have so that we keep the ratio of 1 is to 15? Now how can I calculate this? 1 is to 15 as x is to 400. Now how will I convert these 15 students to 400 students? I will multiply by some multiplicand m. I am just using the term m because we are multiplying it by a multiplicand. So 15 multiplied by some multiplicand gives us 400. And 1 multiplied by that same multiplicand will give us x. I will repeat. 15 multiplied by some number, some multiplicand will give us 400, and 1 multiplied by the same number will give us x. So what is this m? What is this m? It's quite simple. If 15 multiplied by m is 400, 15 times m is 400, then 400 divided by 15 gives us m. 400 divided by 15 gives us m. Okay. And we can put it in the form of an equation because we will also know that x divided by 1 will also give us m. Since 400 divided by 15 gave us m, x divided by 1 should also give us m. Why? Because 1 times m gave us x. So since this is m and this is also m, we can say that they are equal. Since 400 divided by 15 is m and x divided by 1 is m, we can say they are equal. So we get an equation: 400 divided by 15 equals x upon 1. Of course, we know x upon 1 is x, and 400 divided by 15 is 80 upon 3, which is 26.33 teachers. This means that our school needs more than 26 teachers to get the ratio of 1 is to 15. We can rewrite our original proportion as 1 is to 15 as 26.3 is to 400. Of course, we cannot get 0.3 teachers. So this means we need more than 26 teachers in order to get that proportion. Let's end this section by looking at one more example. So let's say I have some other ratio, 3 is to 5 as 51 is to what? I want to find out. I want to scale 3 is to 5. I want to scale it up. So 3 times some multiplicand m gave me 51, and 5 times the same multiplicand gave me the term I am looking for. So let us just look at this. Instead of using x, I have used a question mark. You can use x, y, anything. So 51, so what do we get? 51 upon 3. What is 51 upon 3? It will give us m. And what will this question mark divided by 5 give us? It will also give us m. Since this gives us m and this also gives us m, they must be equal. And therefore, the question mark we are searching for equals. Now, how will we do this? Now we have to do it like an algebraic sum. So 51 upon 3 equals something upon 5. So to find this something, let's call it y if you want to. How will we find it out? Well, we can move this term across the equals to. Since this is being divided by 5, when we move it across the equals to, we will be multiplying it. I hope you remember your algebra. So this number we are searching for equals 51 multiplied by 5 upon 3. And if you calculate it, it turns out to be 85. What we get as our answer is 3 is to 5 as 51 is to 85.